In this video, we're again going to continue our discussion on inverses, and specifically we're going to describe different ways of expressing the inverse. So I'm going to do that by an example, and basically this example over here is this function. So if you basically copied this function before, I just literally just copied and pasted it. So here's f of x, and its coordinates, these edge points are 1, 2, 2, 3, and 3, 5. And this green line here represents the inverse. So all I did was I just wrote an xy table, I switched the inputs and outputs, and then I graphed that. So here we see f of x and f inverse. So one of the things to notice sort of graphically when we see this is that we've studied something on reflections. And the two types of reflections that we've studied so far are reflection across, say, the x-axis. And a reflection across the x-axis would make this yellow line look something like that. And a reflection across the y-axis would make our yellow line look something like that. All right, so you don't have to draw these lines. I was just trying to show you. But if you look sort of carefully, I'm going to erase this and I'm going to erase that. So you please do not draw those lines. That's not what I'm trying to demonstrate. I was just trying to demonstrate that those were sort of reflections that we've studied so far. But if you observe, these two look very, very similar. And in fact, what it is that it's actually f of inverse of x can be expressed as a reflection of f of x. But it won't be around the x-axis, nor will it be around the y-axis. And the actual line that it can reflect over is the following. So basically, imagine if I drew a line over here, right? And let's say this line served as a mirror. Then we can clearly see if this was a mirror, the reflection of f of x would be equivalent to f inverse of x. So the question is, what is this line? And this line happens to be y equals x. So in other words, y equals x, if you think about y, so I'm just going to rewrite it again, y equals x. So if you think about it, that's the slope of 1 and there's no intercept. And so if you reflect anything, if you reflect any function over y equals x, what you will see is actually the image that you get over y equals x is actually simply f inverse. And that's basically a very, very important thing to know. So one of the ways to express the inverse, so say for example, so here's an example. So let's say for example there's a function f of x. So let's say let f of x, so it's any function, let f of x be reflected across g of x, not g of x, pardon me, reflected across y equals x to be transformed to g of x. All right. So then, what is the relationship? What is the relationship between f of x and g of x? Well, let's basically investigate this question again, right? So let's say we have f of x right here, and we reflect it across this line, we get its inverse. So according to this question, let f of x be reflected across y equals x to be transformed to g of x, then the relationship of f of x and g of x must be that they are inverses of each other. So in other words, g of x is equal to the inverse of f of x. So the solution is that all you would say is that g of x is equal to f inverse of x. And that's it. So in other words, or you could say f and g are inverses of each other. All right? So the key thing to remember is that if you're ever told reflected across y equals x, what that means is that what we're trying to do then, it's screaming that we have to find the inverse of the function. In the next video, I'll give you an example of this. So see you then.